Okay, this is a video on finding inverses of functions algebraically. I'm going to do a couple of examples with you just to try to show you how we're going to do this, and it is as simple as we start out. And when we talk about inverses of a function, we're talking about changing the x and y values, or the input and output values. So algebraically, we're going to swap the x and the y and then solve for y, and you'll see what the equation for the inverse function would be. So just what I'm talking about, f of x, that's the same thing as y equals x, and then what we would do is we would switch the x and the y and then solve for y. So the thing that's maybe a little bit strange here when we start to do that on some of these other functions is that you're going to have to do that swap and then do a fair amount of algebra to get the y by itself. So here we go. Let's see how it goes. So this is y equals 6x minus 3, and to make the inverse, what we're going to do is x is equal to 6y minus 3. So what we're looking for is the inverse of this function here. All right, so let's go ahead and do that. So I'm trying to get y by itself. That means everybody away from y. So inverse operations. And we're doing the reverse order of operations. So adding to get rid of subtraction. And that's going to result with x plus 3 is equal to 6y. And now I need to get rid of multiplication or undo multiplication by dividing everything by 6. So then now I've got these to be able to cancel out. So I've got 1/6 x plus 1/2 equals y, or y equals 1/6 x plus 1/2. This would be the inverse of this. That's how we're going to do that. Example, we're going to do an inverse of a quadratic function. So y equals x squared plus 2. We're going to find its inverse. So go ahead and swap your x and your y values to create a different function, and now we're going to try to get y by itself. So subtract 2 from both sides. X minus 2 is equal to y squared. And how do I undo squaring something? That's going to be square root. So I'm going to take the square root of both sides, and I'm now going to have these two cancel out, and I've got y is equal to the square root of x minus 2. Okay, now we got a cubic function. So we're going to do an inverse of this cubic function. So that means that I'm looking for x equals y minus 1 to the third power plus 2. And I'm trying to get y by itself. So everybody away from the parentheses. Subtract 2 from both sides. X minus 2 is equal to quantity y minus 1 to the third power. Now, how do I undo? I could take the cube root, or I can raise it to the 1/3 power. Either one is going to help me get rid of or do the inverse of raising something to the third power. So we'll do cube root of both sides, and these will cancel each other out, and I've got the cube root x minus 2 is equal to y minus 1, and then add 1 to both sides in order to get y by itself. So now I could say that y is equal to the cube root of x minus 2 plus 1. And this is the inverse of what this function is, and it's just a cube root function that translates right to an up 1. Okay, now we're going to do an inverse of a rational function. So that would be x on the bottom, or a negative exponent, x to the negative 1 power. So what we're going to do is go ahead and swap our x and our y's, and we're trying to get y by itself. Now, one of the things that might be helpful is to go ahead and turn this into a proportion so that I now have a fraction equals a fraction, which would allow me to cross multiply. So x times y is xy, and 1 times 2 is just 2. Now, in order to get y by itself, I would divide both sides by x, and now I'm left with y equals 2 over x. Interesting about that is the exact same thing we started with. Finding the inverse of a function graphically is here. So what I've done is I've gone ahead and graphed this linear function f of x equals 4x minus 3. I've gotten the coordinates. I started out by using the y-intercept, graphing it, and then using my slope of 4 over 1 or up 4, right 1. And I got this collection of points. I've listed their coordinates here. So then what we've talked about is that the function's inverse is going to switch the x and the y values. So let's just fill in this table real quick. So now we would have -7, -1, -3, 0. And all I'm doing is swapping the x and the y values, 5, 2, 9, 3. And those 5 points are what we're going to graph for our inverse function. So -7, -1, that's left 7, 1, 2, 3, 4, 5, 6, 7, down 1, left 3, 0, right 1, 1, right 5, 1, 2, 3, 4, 5, up 2, and finally right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3, 1, 2, 3. And these points would make up our inverse function.
Okay, I wanted to make an additional portion of this video for our inverses of functions, or finding inverses of functions video, just because I wanted to answer a couple of questions that are starting to come up, and I just wanted to give you a little help. Okay, so I have a quadratic graphed on our screen here, and then I've also gone ahead and graphed its inverse. All I've done is switch the x and the y values from the quadratic that they started with, and then that was what gave me this red graph over here. Now, everything seems okay. Quadratic slid over to the right. That seems like a reasonable inverse. It does look like a rotation. It does look like that everything seems to be in order, but tiny issue, this red function is not a function. It does not pass the vertical line test, but more importantly, a better way of describing that is it's not a one-to-one function, meaning each of our x values do not have a unique y value. So we have multiple x values, like 7 or 4 have different y values. So we can't have the same x value with multiple y values and it still be a function. So one of the things that you have to just be cautious of is when you find the inverse of a quadratic, you typically will end up with a square root function, and the square root function is only this portion of our graph in order to make sure that it is indeed a function. So I wanted to point that out to you guys to make that very clear, that the portions of our graph that were below and would end up giving us those multiple values, that's where we run into problems. So just be cautious of that. All right, the other thing I want to point out is up here, I did another example for you, and I just wanted to point out right here, this notation that's incredibly important. When you write the function, your final product, you know that you found the inverse of the function. We use this notation here, f inverse of x. So that -1, it helps our readers understand that I've taken the original function f of x and I found its inverse, and this is what it is. So make sure you use this notation. Don't leave it as y equals. Make sure you go ahead and write the notation f inverse of x using that -1.